All right, good to go?
Yeah.
All right. Well, first and foremost, hello everyone. Good afternoon. Thank you for taking some time out of your day to come meet with us. Our webinar, Scaling .NET Apps with In-Memory Distributed Caching, is an oldie but goodie. It's more of a high-level introduction, to our caching solutions and products. My name's Adam Keller. I am the regional director of service delivery. So essentially, I'm the liaison between customers that are evaluating and our internal engineering team. With me is Ron, and Ron is our lead solutions architect. He has over 10 years of enterprise level experience. He's very, very, very involved with our customers as far as setting up configurations, implementations, technical talk. So due to that exposure, he's very pivotal in our roadmap where we take the product. So you're in good hands today. Any questions that you have, you'll see a tab at the bottom of the go to webinar pane. Ask away. That's what we're here for, and we want to make sure all your questions are answered. So with that, I'm going to pass it over to Ron.
Thank you very much, Adam. All right, everybody. My name is Ron. I'll be your presenter for today's webinar. The topic that we've chosen is scaling .NET apps with distributed caching system. I'll focus on .NET applications, .NET technologies, all the different types of .NET applications that you typically have in your environment, the bottlenecks associated with those applications, and then I'll present solution to handle those bottlenecks. I'll be using NCache as an example prior for this. I'll also share some details around the general technology, the distributed cache as a technology. But I'll be using NCache as an example. That's the main distributed caching product that we offer at Logisoft. So if everybody can see my screen, everybody can hear me fine, let me quickly get started with this. So first of all, there are a few slides at the beginning that are focused on a few terms that I'll be using quite frequently within this webinar. So I'll start off with explaining what is scalability. Now, scalability is an ability within your application architecture that allows it to handle more and more requests at a given time. So you increase the capacity of how many requests you can handle, and at the same time it does not compromise on the performance. So if you have that ability where under 5 users your applications perform in a certain way, and I would expect that they would perform in a fast manner. If you have 5,000 users, 50,000 users, or 500,000 users, it should, for individual requests, it should perform on the same line. And at the same time, all those congruent requests should be handled. So it's a combination of throughput and latency. More throughput, less latency, and that's what I would categorize as scalability. Now, if you have high application performance under peak loads, I would just call, just say that your application has a scalable architecture. If you have a performance problems at 5 users, then you have some dire problems, some serious problems within your application. So that's something that you need to look into application architecture. But assuming your application works fine under less load, and if it works fine under peak loads as well, that is a scalable system. Then we have a linear scalability. Linear scalability is an ability to keep on increasing that capacity. More and more throughput can be achieved from a system by adding multiple resources, more and more resources. So on a horizontal line we have servers, and on a vertical line we have transactions capacity, transactions per second. And you can see as we add number of servers, these work in parallel, and they contribute towards request handling capacity. And that's the whole idea of a scalable system, where you add more resources, you get more and more transactional capacity out of the system. And NCache exactly does that. It allows you to handle more requests, more throughput out of the system for your applications with the help of NCache, and at the same time improves your performance as well. So it does not compromise on the performance. And this is an example of a non-linearly scalable system, where after a certain time or certain requests load, it actually becomes a straight line. Or in some cases it degrades your performance, where some requests are pending operation, where they're queued, while other requests are being processed, and server is being maxed. Or database is a typical example of it. where you can scale up the database. You can put more and more hardware, but there's a limit to how much hardware you can afford. And it's a single instance. It is not going to scale out after a certain capacity if you have hit that capacity. If you haven't hit the capacity and your application is working fine, then most likely your application does not need scalability. But if assuming that your application does need scalability, and load keeps growing, so there are systems which would not scale out. They would give you performance implications at the same time throughput implications.
Quick question, Ron. How's the latency affected when requests per second increase?
Right. Okay. So with that's a typical scenario, right? That's a very common question. Since scalability is a combination of two things, it's more throughput, less latency. So with a scalable system such as NCache, your latency should not go up, right? So if you're able to handle a request, say in sub-milliseconds, 5 milliseconds, or less than a millisecond, and you're able to handle 5 or 10 of those requests at a given time, you should be able to have the same kind of latency, less latency, and at the same time under 50,000 users, or 500,000 users, or 5 million users in some scenarios. So the idea behind scalable systems is that your latency should not go up, and these go hand in hand. These are always treated side by side, where latency and throughput are a combination of each other, where that's what you use to measure your scalability. So you should have low latency, it should not increase, so performance should not go down, and at the same time you should be able to have a lot of such requests, huge amount of requests, extreme transactional processing within your system. I hope that answers your question. All right, so now that we've defined systems and then their ability to scale out, scalable and non-scalable systems, what are the applications within .NET that need scalability? So it could be your web applications. Typical platform for it is ASP.NET on the .NET end. You can have web forms or MVC based web applications, and these could be front end e-commerce systems, airline ticketing systems, some stock management, some financial systems. And idea here is if these are public facing front end systems, you may have a lot of users logging in and getting information out of it. So it could be a lot of concurrent users, and they can have a lot of concurrent requests associated with them. So they may be handling a lot of users per day, per hour, or at any given time. There could be some backend or front-end web services, WCF, or any other technologies that you must be using, handling a lot of requests. It could be Internet of Things. You have a lot of interfaces, some hardware, some backend systems that you're managing through IoT. So that could also process a lot of requests through, and they are candidates for scalability. And then we have a common buzzword these days, big data processing and grid computing. So you may have to process a lot of, data, a lot of data through distribution or multiple servers, and that is something that's a prime candidate for scalability. So in a nutshell, it's any system which needs to process huge amount of request load, that is a prime candidate for scalability. So these are the applications which would need scalability as a must. You cannot afford to lose on the scalability end, where a system chokes down under extreme load, or it actually increases the latency. So your end user experience would be hurt based on that. The scalability problem. So let's actually build some more details around it. Let's build the concept. So where exactly is the scalability problem? We have identified that there are systems which are scalable, then there are systems which are not scalable. So within an application tier, application structure, application architecture, there could be multiple tiers. You have an application tier, and then you have a database tier or storage tier. So your application tier scales out nicely. It can scale up. You can add more resources within web server. You can create a web garden, and then you can also create a web farm, and then you can have multiple servers hosting your applications, and requests are handled in a distributed manner on all those application resources. But they always talk to a storage tier, and typically it's a relational database, SQL or Oracle. It could be a mainframe data, it could be a file system, it could be any legacy backend data storage, where your all web form, servers within the web form are connected and getting data back and forth. So databases are slow to start off, and then they're not equipped to handle extreme transactional processing. And this diagram illustrates it quite nicely, where we have a scalable tier. We can put a load balancer in front of a web form, route requests to all the resources within this web form. So you can have multiple web servers joined together, pooled together. They're handling requests in a equal distribution, round robin, sticky. You can come up with load balancing algorithms. But based on that, you can scale out on this tier, but you end up talking to a backend storage, which is typically a database, or it's an ASP.NET session storage, or it could be any other file system or user data that you may need, or it could be another web service, by the way, another application that you connect to. But this tier is not scalable because it's typically a single server. That is the case with database. It's used with it can have mirroring turned on, but that's for the backup. But at any given time, you have one server handling all your request load. So that poses a scalability bottleneck. It's slow to start off, and it's not scalable. You lose your capacity, you lose your throughput, and you eventually lose your performance as well. So you have high latency and less throughput after a certain time. So you end up with this kind of graph. After a certain load, when you hit the capacity of your backend data source servers, the hardware is maxed out. You don't have any ability to add more load. You just have to wait for your request to be fulfilled. After a delay, they're queued, and that impacts the end users which are using your application. So that's the main problem that we're trying to address within this. And sometimes people recommend using NoSQL as a technology that can take care of scalability problems. Yes, it does, but essentially NoSQL is a replacement of your relational database. So you need to architecture your application in such a way that it starts using NoSQL and replaces relational database. And it's also for unstructured data, which is loosely coupled. So that's another problem. So you may have to re-architecture your application. So idea should be that you should have this ability of scalability. You should scale out with minimal or no changes inside your application architecture, and that's what we'll be focusing today. Alright, so solution to this problem is very simple, that you use an in-memory distributed caching system, which is very scalable, it's very fast, it's highly available, and very reliable. So these are some of the characteristics that I'll be explaining in incoming slides. So what is an in-memory distributed cache? Now that we've built concepts around scalable systems, non-scalable systems, and data storage is typically a scalability bottleneck where your application can scale out, database cannot. What is the solution? And solution is to use an in-memory distributed cache. So these are some characteristics, some core requirements that your distributed cache must fulfill. I've just picked these from NCache features, but this is a general guideline that this is the system requirements that you need inside a distributed cache in order to handle the scalability problem. So first of all, a distributed caching system is a cluster of multiple cache servers. So it's a cluster, it's not a single source. That is the starting point, and these should be inexpensive, right? So I would recommend or I would prefer a system which is easily manageable on the cost as well as from a maintenance standpoint. So it could be a web server, app server kind of configuration. It can even be the same tier, right? You can have your own app servers, web servers used as caching servers. It depends how much hardware you have. Nice thing about this cache cluster is that it should pool the memory and CPU capacity, and that's what NCache does. It allows you to pool the memory and computational power into a logical capacity, so you end up connecting to a cache, a named cache, but behind the scenes there are multiple servers hosting that cache. So it's a cluster of inexpensive cache servers. Second characteristic is data consistency, right? And it is between the servers in the cache cluster. You can have 2-3 caching servers which are part of the same cache repository. Data is distributed. Some data exists on server 1, some data exists on server 2, and some on server 3, and so on and so forth. And there's another scenario. Data exists in the cache as well as in the database, right? So you use a distributed cache in addition to a relational database. So you need to make sure that everything is synchronized, right? So there are features that you can use to synchronize cache with your data source, and all the cache updates within the cluster are visible to all other caching servers. So it's consistent in terms of updates. Any data that you update or add on server 1, it is also known to server 2 and server 3. So there are no stale data or inconsistent results from the distributed caching system because it's a distributed system in nature. Third characteristic, and this is the most important one in terms of scalability, it should scale out linearly for request handling capacity. Right, it should increase the throughput and without compromising on the performance, as we covered earlier. So your performance should be improved. It's in memory, right? So it's super fast already, but that performance should not go down when you have a lot of load coming in, right? So you can add more servers to accommodate the increased load, and you should be able to keep on doing that. So you should have a linear graph where you keep on adding more servers to the distributed caching system, and it scales out on the request handling capacity, more reads per second and writes per second, and performance also remains intact. So that's the guideline for it. So it's a linearly scalable system where you can add more servers to grow capacity, and this should not be done in an offline manner. It should be done on the fly. Running servers, running cache cluster can allow or should allow to have more and more servers added to it, and this is exactly what NCache does. And fourth feature is around high availability and data reliability. If your system demands data that you need as a must, it should be highly available. It should not have any data loss if a server goes down, or if it's in regards to maintenance. Data replication becomes a very important feature. And high availability, connection failover support, and all those self-healing mechanism in the cluster where server can go down, new servers can be added, and it should not impact the end clients. So that covers under gets covered under reliability features within the distributed cache. So all of these features are part of NCache. As I mentioned, that I picked these characteristics from NCache feature list, and these would eventually resolve all the scalability bottlenecks based on the features. And next I'll position the discussion in such a way that I'll talk about deployment of distributed cache, give you a hands-on demo, and then talk about some of the features. Any questions at this point? All right. Assuming that since we're building the discussion, so I'll cover this slide and then we'll move on to our hands-on portion. This is a typical deployment of a distributed cache, and as I mentioned, that you can always use it in combination to our relational database. It's not a replacement of your conventional relational data sources. It's something which is used in combination to our relational data source, unlike NoSQL technologies, which demand replacement of relational data sources and pointing towards NoSQL data sources. Right, so this is how you would create a cache cluster. You can start off with 2 to 3 caching servers. Dedicated tier is recommended, and then your applications connect to it in a client server model. So you can have one big centralized cache tier, or you could have respective cache tiers for each of your application forms, and essentially all your applications can connect to it. Multiple applications can connect to the same form. Preferred platform is 64-bit. All Windows environments are supported 2008, 2012, 2016. Only prereq is .NET 4.0. So it's native 100% .NET product, NCache, and it allows you to create a cache cluster, and your applications connect to it. And idea here is that you use it for ASP.NET sessions for data that most frequently accessed, and in your application you can check whether data exists in the cache. If it's found there, very good, you don't have to go to the database, so your expensive database trips are saved. And this tier is very scalable in comparison. Multiple servers are there, it's very consistent for updates, it can scale out linearly, and it has replication support also built into it. On top of it, if something is not found in the cache, it's your application which can either go to the database and add it to the cache for the subsequent request, or you can use some data access layer providers, read through and write through providers, which is your code that you implement. There are interfaces that you implement and register with us, and then we can call that code on behalf of your application. So your entire data access layer logic can be made part of NCache. So your application only talks to NCache, a scalable medium, and then NCache in turn talks to backend sources if needed. So that's an add-on feature that you can implement and turn on. Any questions on the deployment architecture of NCache? It can be hosted in all environments, VMs, physical. It can be hosted on-prem as well as in cloud environments. It's available in Microsoft Azure as well as Amazon and any other hosting provider as well.
Ron, I have a excuse me. I have a question. What happens if I have like a smaller deployment, and I don't have a caching tier? Can I just put NCache on the web servers, the app server?
Yeah, absolutely. So this is a very common question, and typically for smaller deployments. So NCache presents both options. One option is that you have dedicated tier, dedicated servers, and your application forms have their own dedicated servers. So there are 2 tiers, NCache tier and your client application tier. But for smaller configurations, and this is a typical question, that what if we have 2 or 3 web servers and that's all we have, and we would still like to use a distributed cache? You can very well do that. Another option is that you use the same tier for caching as well. So if you have two web servers, you just install NCache on the same boxes, and it's still a distributed cache. It's just that it's sharing a resources, hardware resources from the same tier, right? And you need to make sure that you have enough CPU power, memory, and networking power to support NCache as well as your application. So it works absolutely fine, no limitation from our end, and that's a common deployment for smaller configurations. But again, the recommended approach is to have a dedicated tier. That's where you get more benefits in terms of dedicated nature of resources for from a hardware standpoint. Your maintenance becomes a lot easier. You can add or remove servers and without affecting client application tiers and vice versa. All right. Moving on, we'll talk about some common use cases. Next question that you may have in your minds would be, how do you use a distributed cache? What are the common use cases? It's typically used to save expensive database trips. You can use it for data caching. It scales out nicely. It's fast to start off in comparison to database, and then database can choke down. We've already established that under peak loads. So to avoid those issues and to avoid expensive database trips and to avoid any scalability bottlenecks that you may have, and in some cases it could be a reliability or maintenance related issue with database, you can use a distributed cache. And application data caching involves NCache API, which is right here. Pretty intuitive, similar to HTTP runtime API. You can call API and get connected to it, and then you store everything in a key value pair. Within our data caching, you can cache almost anything. It could be your domain objects, collections, data sets, application objects. Any sort of application related data can be cached using our data caching model, and gives you full control. There are lots and lots of features which I'll highlight once we cover the hands-on portion. So that's our first use case, and you can use it in backend systems such as web services, Windows services. It could be also front-end systems, so it's very flexible on that. It's a .NET API. Any application that can include it, you can use it. ASP.NET specific caching. This is primarily the web application, the front-end caching features within the distributed cache. We have ASP.NET Session State Provider implemented. It's a single site and multi-site. You can have two different sites and still share sessions, or it could be a single site, a typical web form. You may have in-proc, state service, or database as your session state modes. You can completely replace those, and we have a provider which can be implemented without any code changes. NCache gives you additional benefits on top of what is available on from Microsoft ASP.NET support. NCache is a fully distributed model. It's a no single point of failure. You can scale out linearly. You can add as many servers to host your session. Your web servers become completely stateless. Your maintenance becomes a lot easier. Sessions are replicated across servers, so it is very reliable, and everything without any code changes. You don't have to use sticky sessions anymore that you must use in case of inproc. And in comparison to database and state service, it's fast and more scalable, and also more reliable. No single point of failure. Then we have view state provider, that is for web forms. If you have MVC, you would not need view state caching, but for web forms do construct view states. If you have a lot of widgets, a lot of controls on your web forms, on your application pages, chances are that you're dealing with a lot of view state, and you can just right click on the page and then choose view source, and you would see the view state packet inside your browser. So each time you request an HTTP page, a web form, that constructs view state, and that's sent back to the browser. And on the browser end, it's never really used. It's sent there so that it's brought back to the server. And on the server end, when you post back, that's when we use the view state. So view state become heavy over a period of time if you have a lot of controls, a lot of users. So it eats up your bandwidth, and at the same time, your request and response payloads become heavier. So it's a performance degradation issue as well. With NCache, you can plug in our provider, and view states get stored in the server end. You don't have to send the view state back to the browser, so your bandwidth utilization cost goes down and your performance goes up because your payload becomes smaller, and now your system is more scalable because now you can handle more and more requests using more throughput from the bandwidth as well as from the distributed caching store. So it's more scalable system, and this is also a no code change option. Third feature on the web front end caching is our output caching provider. All right, so you can plug in our output cache provider, and it's based on ASP.NET output cache provider, but it's distributed in nature. So we resolve all the issues that you would have with ASP.NET in prog output caching. NCache is out of process. It would not ask you to have redundant data inside each worker process, and it's scalable in comparison. And idea here is that you cache the static content. If the entire page is static or portions within the page are static, you don't need to re-render or execute or specifically go to the backend databases. You can present a page output if the request is asking for the same data. For example, you have product catalogs. You've displayed the products, and each time a user comes onto your e-commerce site, it's requesting the same products, right? It's a page or number of pages that need the same data to be presented, and that data may change every few hours or every day or every few days. So as long as that data is valid, you don't need to re-execute those pages. Present a page output directly to the end users. And then there's a SignalR use case as well. I should update the slides. So NCache can be used as a SignalR backplane, and this is also no code change option. So for web front end side of the things, there are no code change options as well, other than data caching. So you can use session state caching without any code changes, view state caching without any code changes, output cache, and SignalR backplane use cases, and this is all no code change options, just minor web config changes. And I'll show you these samples once we move on to our hands-on portion. Third use case of a distributed caching is through runtime data sharing. It can also be used as a messaging platform, a message bus. We have powerful pub sub model. You can have publishers and subscribers, and there are channels, some topics that you can assign interest to or show interest to get registered, and all the messages for a specific topic, specific channel are sent to all the subscribers. So publisher can publish message, subscribers receive it, and there could be multiple of such topics. It's very scalable, very fast, very reliable, and SignalR implementation of ours is actually based on this pub sub model. And this PubSub model can directly be used in the application as well. On top of it, you can get notified if data changes in the cache. Data gets updated, notified about it. Data gets added, removed, you still get notified about it. And you can also set up a criteria about a data set in the cache. If you're only interested in products where product price is less than 100, so you can get notified if that data set changes, right? So that's another feature that you can use, where NCache can be used as a runtime data sharing platform, which is very scalable, very fast, and very interactive with the help of these features. Some of our clients which are using NCache, we have banking industry, e-commerce, airlines, some financials, as well as health industry, auto industry. So list goes on. It has been in the market for over 12 years. Lots of traction, lots of actual deployments in the market. Excuse me. Alright, so I'll quickly take you to our demo environment, show you the product in action now that we've built enough concepts around the technology, how it handles the scalability side of things. We'll talk about it once we actually move on to our hands-on environment. So let me just take you to our demo environment. Demo 1 and demo 2 are two boxes. Let me just log on to demo 2 as well. Alright, so NCache is very easy to set up. All you need to do is go ahead and download our fully working trial. As a matter of fact, it's 4.8 version, which is currently available on our website. So we have a 30 days trial. This can be extended into 60 days, so that's what makes it a fully functional trial once you request a 60-day trial key. Right, so step number 1 is that you download our product from our website and install it on all your cache servers and clients. I've already done that. I have installed NCache on demo 1. That's first box, and I've also installed NCache on demo 2 as well. We have a deployment, and on my machine I've installed the client portion. So once you download the installer, it presents you with the options of choosing the server installation or the client installation, so you can pick accordingly. Next thing is that you create a distributed cache, a cache cluster, right? So for that, you can use the management base GUI based management tool, or you can also use the PowerShell or command lines for that matter. With 4.8, we've changed all our tools to PowerShell, so it's very easy to utilize those. Alright, so I'll just use the GUI tool, and step 2 is to create a named cache, right? So all caches need to be named. uh, my cache is demo cache. It's not case sensitive, so I can just be, and I'll keep everything default here. Caching topologies, that's a segment that I will see if I can cover towards the end, but there are many caching topologies that you can pick from. NCache cluster is a TCP/IP based cache cluster. It's highly available. All servers are peer-to-peer architecture. You can add or remove servers on the fly, so any unplanned outage or a maintenance use case does not impact the client. So as long as you have one server up and running, there's no data loss, no application downtime. And on top of it, connection failover support is built into the clients. Any server going down, clients automatically detect that and they fail over the connections and start using the survivor nodes. So it presents you with 100% uptime, a highly available cache scenario. So this is something that's built into the protocol. So that's another benefit that you get out of it. Since I explained these are the characteristics, so these were based on the dynamic cache clustering protocol of NCache. Caching topologies, you can use partitioned. Data is fully distributed, no backups. You can use partitioned. Data is fully distributed. Server 1's backup is on 2, server 2's backup is on 1. And all clients are connected. It's very intelligent in terms of sharing all the resources, data distribution, and clients getting notified about new servers getting added or servers going down or existing partitioning of data. So reads are very fast in this topology, writes are very fast in the topology, and on top of it, it's very reliable. If any server goes down, there's no data loss, no application downtime. And this is the same topology with 3 servers. Server 1's backup on 2, server 2's backup on 3, server 3's backup on 1. If any server goes down, the backup of that server gets activated, so there's no downtime, no data loss, and that gets divided, merged into the other server's active partition, and new actives and backups are formulated. So you end up getting the same 2-node cache cluster, healthy node, automatically. And it's completely a seamless process for your application's standpoint. And cluster heals itself automatically. Okay, there is a page on our website that you can review for all the details on caching topologies. If you go to products and cache, there's a segment where you can refer to caching topologies. It's awfully slow today. Yeah, so caching topologies is the main page that you can log on to and see what is available in terms of architectural details of all these caching topologies. So that's the page. I'll wait for it to come. There you go. So this covers all the caching topologies and all the use case details for each of these caching topologies along with diagrams. So I'll just go ahead and pick demo 1, demo 2 as my 2 servers. Partition replica cache is the topology with the async option, and demo 1 and demo 2 are going to be initial servers which are going to host my cache. These are the server installation, TCP/IP port for communication, size of the cache cluster. I'll just keep 1 gig because I have 2 servers, 1 gig from each server. And then if cache becomes full, I can either reject new updates or I can turn off evictions. Evictions can be turned off if your data is of sensitive nature, but typically you can turn on eviction and it would automatically make room for the new items by removing some existing data automatically. So it keeps a sliding window where it keeps removing data and new data can get added. And I'll auto start this cache so that each time server gets rebooted, it automatically joins the cache cluster, so I don't have to manually do that. And that's it. That's how easy it is to set up. So my cache has been configured. I now need to add the client node. So I'll add my box, and my client side configurations are updated. And that's how simple it is to quickly create client and create a cache cluster and add a client to it. I'll start and test this cache cluster, and then I'll move on to our object caching segment. So I'll spend last 15 minutes on our features that you can use, database synchronization and some searching mechanism and some object caching support within the distributed cache. I'll right click and choose statistics. That would open performance counters, and I'll also right click and choose monitor cluster. So step 2 was to create a cluster, step 3 was to add a client, step 4 is to start and test this cache cluster. So I'll quickly do that. I'll run a stress testing tool application which comes installed with NCache from my machine, and as soon as I provide the name, it would automatically pick the server IPs from the configurations. I can pass those IPs in the code as well, and it would get connected to the cache, and you can see the activity already being generated and requests are coming in. both servers are taking requests, about 3 to 400 requests per second by each server. Actives are taking requests, backups are being formulated behind the scenes. I'll just go ahead and add another instance of the same stress testing tool from the server itself. So that should answer the question of running the applications on the same boxes where cache is also running. So that's also possible. And as soon as I would run the second instance, it would just increase the capacity. It would increase the number of requests. About 16 to 1700 requests per second are being handled by another server. So it's scaling out already. And you can see that there isn't any capacity issues on the server end, right? They're coping up pretty well. And even if they do, you don't have to worry about anything. You can add another server on the fly. So I can just run another instance of this tool so that I want to further bump up the load. I'll quickly do that, and as soon as I have hit enter, it has further increased the capacity of requests at given time. And responses are still in sub-millisecond delay. You can review the client-side counters. Those would not show you any contention, but they're increasing in volumes as you keep on adding more and more load, and you can still see that the servers are not being maxed out or showing any contention. And even if they do, for example, there could be a scenario where your request load is say about 2500 on server 1, 2500 requests per second on server 2, and this is for average 1 kilobyte object size. If your servers show signs of contention, where we have a lot of requests, a lot of activity, and servers are maxed out on the hardware, all you need to do is come right here and add right click on the server nodes and choose add node, and you can add a new server on the fly, and that's it. Alright, demo cache already exists on 114, so that's a problem. So let me just log on to 114. Go ahead, Adam. Is there a question?
Just a quick question. What do you have running in the background that populates the graph, the UI?
All right. So for NCache monitor tool, we have perf counters. These are Windows performance monitor counters. So you can also use, since you've asked this question, so I'll quickly highlight Windows performance monitor. I can quickly add the same counters in Windows performance monitor as well. So it's all Windows performance monitor driven, and you can use this tool or any third-party tool to review all these counters as well. So these are the same counters that I'm using in NCache monitor automatically. NCache monitor automatically creates these graphs, but you can use your own monitoring or third-party monitoring for this, and Windows Perf is the technology behind the scenes. Alright, so I wanted to highlight alright, so I may have to clean the demo. Let me just add the manager and get rid of the cache from here, and then I'll quickly add it back to the demo cache cluster. I think it's running a single node cache cluster of its own, so I was playing around with it. Let me just quickly fix it. There you go. So I just need to unregister it. It's an eval, so actually it got added here, right? So so I may have to do this. Please bear with me, guys. Let me just quickly fix this issue. I should have set up the environment, but I can manually take care of it. I don't want to impact the cache cluster, so I will just manually get rid of this cache and then add it to the cache cluster there. So here's a cache segment, and I'll just use this opportunity to show you the cache config section as well. So that should take care of it, and then I just need to restart NCache service in this box. so that this gets picked. It's not a recommended step, but I've just did it so that I can complete the demo and then focus on other aspects real quick. All right, I think we're good. I should not get this error anymore on this box that this cache already exists on it as a single node. There you go. So I can now add this and start this cache cluster. Right, so 25,000 requests per second on average on 2 servers. Now I added a third server on the fly, and you can see how you can scale out from this situation. I can just click close on this and add new counters, and you should, and I'll also see if I can, now we have 3 servers instead of 2, some graphs, and we have capacity going down, but it's not really going down. Previously there were about 2,000 to 3,000 requests per second, but now we have 3 servers, so that request load has been balanced between 3 servers instead of 2. So I'll just show you the updated statistics, and that should actually clarify this. Now we have 3 servers, so we have request load come down on actually 200 to 300, 600 to 700 requests per second on average by each server. Right, so third server has joined, and that is running a limited capacity trial, so that's also not contributing as much. So it's limited to have 200 requests per second at max, but other servers are taking the request load pretty well. Alright, so that helps illustrates the scalability side of things. Next thing that I'll quickly demonstrate is the use case from application standpoint. You can use samples. We have .NET sample, so you can use it in ASP.NET sessions, and this ASP, and it could also be used in ASP.NET web forms, MVC, regular ASP.NET framework, or it could be ASP.NET Core or .NET Core framework. So it's entirely up to you. It's supported on all platforms. And all you need to do in order to use NCache for web front-end caching, for session caching, you plug in our provider. You need an assembly reference right here, and then you need a session state tag, and all you need to do is provide the name of the cache. Right, so here is the name of the cache, such as we're using partition cache, but I'll just change it to demo cache, and that should take care of it. And if I save and run this sample, it would automatically use NCache for ASP.NET session caching. And same goes for web view state caching, as well as for output caching, and then also for SignalR. It's just a provider. SignalR requires you to put one line of code to be used as NCache to be used as a backplane, but that takes care of the rest. Next, you can use our basic operations sample, which comes installed with NCache. It's pretty simple sample. Again, you can find it from the same directory, the samples directory. And once you have included the sample, the steps are that you include alachi.ncache.runtime, alachi.ncache.web assemblies, and based on that you can include a few namespaces, alachi.ncache.runtime and web.caching, and that's it. All you need to do is go through the sample, right, and call ncache initialize cache command, right, and it presents you a cache handle, and then you can use this cache handle to add and update data in the cache. And this sample takes care of all the basic APIs: cache.add, cache.get to retrieve items, cache.insert to update items, and then it can also allow you to remove, delete, so on and so forth. So that covers the basic use case. I'll share more details around this, as much details as possible. Right, so this is the API again. There are lots and lots of features around object caching use case. You have expiration, absolute and sliding expiration. You have our synchronization features. Now that data exists on multiple servers, so data is consistent on the caching servers, but data exists on 2 different places as well. It exists in the database as well as in the application, in the distributed cache. So you can choose to synchronize changes where absolute expiration can invalidate after some time, or it could be if data is being used, it would stay in the cache. If you don't use it, it would get expired. So that would still get you stale data if data was changed in the database, but you were still reading it from the cache. So the other alternative to that would be to time-based dependency. The other alternative would be to use cache database dependencies. So you can set up a dependency between cache objects and the database. Any change in the database would invalidate the item automatically. In some cases, you can reload items as well. And this can apply to non-relational data sources as well, such as file or your custom requirements, some business logic. You can keep checking a web service to present you with a condition. For example, you're monitoring product prices. So if there's a method within the web service that you call, if it returns status that products are changed, you can return true to your custom dependency code, and it could invalidate the associated items. Then you can also have relationships in the distributed cache. There's a separate webinar that I had done on handling relational data in the distributed cache with the help of our cache dependencies and different features, tags, groups, which I'm covering next. You can use relational data in the cache as well, so that also takes care of that problem. Then I talked about data source providers that you can within our deployment. I talked about data access layer providers can be made part of NCache. So you don't have to call database logic in your application anymore if you have these read-through and write-through interfaces implemented. So read-through interface works in such a way that if your cache reads data, if your application reads data from the cache and if it returns null, it doesn't exist in the cache, typically you would get your application to talk to the database. But instead of doing that inside application code, you can implement our read-through interface and call your data access layer providers or your data access layer code directly in the read-through provider, and NCache can call it. So in your API, you just call cache.get, provide a key, and then set up the read-through flag to be true. So if it finds in the cache, it doesn't go to the database. If it doesn't find in the cache, it would go fetch it from the database. Write-through is opposite of it. If you change something in the cache, you would also like to change it in the backend data source. Update, remove, add. So all those can be handled through our write-through provider. So you always deal with a faster source, and it can also be right behind to the database. So database can be updated behind the scenes asynchronously. So you can put a batching or throttling features on the right behind side of things. So idea here is that your data source providers are taking care of all the data access layer logic, and you don't have to do this inside your application anymore. And this can also be used to auto reload data on expiration. So if you link this feature with expirations, data expires in the cache. Instead of removing it, it can call your read through to automatically reload it. So that's an extended feature. Then we have groups, subgroups, tags. So we have logical collections inside the cache. So that's another feature that you can use. This is to add a keyword. You can fetch all the logically associated objects with the help of tags at once, although they're stored individually in the cache. A typical example on top of my head that I can think of is you have orders. All the orders can be decorated with orders tag, or all the customers can be decorated with customer tag. And it could be more than that. You could have all the products which belong to a certain category. That category can act as a tag. And similarly, all the orders of a certain customer can have a customer ID as a tag. So when you need all those orders for a certain customer, you can just say cache get by tag, and it would fetch all the associated objects. It's a way of forming logical collections. And then we have bulk gets, searches. NCache searches are very fast, so you can use SQL and link queries directly on the cache objects. You can select something which can go, you can search items based on their criteria. You can select products from the cache, and it could be product price greater than 10 and product price is less than 100. So it could be a SQL like select statement that you can use. And link is also supported. It's very fast, very scalable, and we also support data indexing, so that makes it even faster.
Hey Ron.
Yeah.
Do you have a second? Do you have time to maybe show us a SQL or a link query?
Absolutely. Yeah. Let's actually review this. Within our samples, if you go to our samples, we have .NET, and we have NCache link sample right here, and then we also have our object query language sample right here, right? So these are the two samples that you can use as a reference, and on top of it we have a very detailed help documentation available as well. So if if you go to our documentation, on the main documentation page, you can review our programmer's guide, and inside programmer's guide you can look up all the examples of object query language. So let me load these. Excuse me. All right, as soon as it gets loaded, it may take some time. Yeah, it's still loading. All right, in the meantime, let me show you the programmer's guide. Right, so if you go to the programmer's guide, on the client side API programming, there is a section on object query language, and within object query language, let's have a look at some of the examples. So we have the reader based approach. Execute reader is the keyword that takes a string key and any criteria, right? So these are some methods that you can call based on the return type and description. The query is very simple. You can select this.category max product.price.id, where this.category equals to something, and group by on the category. So you can provide the values in a iDictionary and then call execute reader, and then you iterate through the records to retrieve the corresponding results that you need. Alright, so this is a sample for the same, and all it's doing is adding a reference to alachisoft.ncache.runtime, alachisoft.ncache.web, and based on that it highlights the API that you need, right? So you could, let's pick one query, and then I think that should be enough. Select Alachisoft product where this.id equals to something, or let's take a slightly advanced one. I think all the examples are pretty straightforward in this. Select Alachisoft.sample.product where this.product name equals something. Like I said, it could be order by, group by, and, or, like. So all those operands are supported. And on the link query, we also have the link support. Let me just quickly show you that. So all you need to do is define your objects with the help of iQueryable, right? And then based on that you can run actual link queries, and those link queries would be applied on the caching objects directly. So that should take care of all the searching mechanism where people don't want to deal with keys themselves. They can actually use the criteria based search. I hope that answers your question, and this also brings us towards the end of our presentation. Please let me know if there are any other questions at this point. I'll just use a couple of minutes to iterate, summarize what we have covered today. We talked about scalability in general, linear scalable systems, non-scalable systems, and then we talked about database scalability issues. And then we presented solution, which was of course distributed caching, which was extremely fast because of in-memory access. It was extremely scalable because you can have multiple servers and you can add on more servers on the fly, and it's very consistent and very reliable and highly available as well. And then there was a deployment, some use cases, and we shown you some hands-on details on how to set up the environment, create a cache, add the client, test it, use it in applications for ASP.NET Sessions as well as for object caching. And towards the end we highlighted some of our object caching APIs, and we have pretty detailed help document available to support all these with examples that you can use as a reference. So please let me know if there are any questions. Otherwise this concludes the technical presentation for this particular topic.
Alrighty, doesn't look like we have any questions. No. Well, thank you for joining us. We appreciate you taking time out of your day. And if you want to have a one-on-one session to excuse me, to demo the product, let us know. We'll go through and show you all the features. If you want to have a technical conversation about your use case, let us know. You can download the product off of our website and evaluate it yourself. Check it out. If you need anything, let us know. We appreciate your time. Thank you.
Thank you.
Thank you, Ron.
Guys. Thank you, guys. Thank you, Adam.